Okay, some more of section 10.3, and this is number 53. And we want to find the area shared by the circle, r equals 2, and the cardioid, r equals 2 times 1 minus the cosine of theta. So again, we'll draw our sketch, and this is our circle, and this is the cardioid, and we want the area that is shared by those, so that would be this area in here that's inside the cardioid and also inside the circle, so this part over here. Well, we could divide that up, and these are kind of geometry tricks. And we've got this little part of the cardioid, and this is this part of the circle, which is that's just 1/4 of a circle. All right. So that shouldn't be hard to figure out. So I broke this up into two parts. This is the cardioid part, and what we're going to do is we're just going to take the integral from 0 to pi over 2 of this cardioid, and that's going to give me this little section over here. All right. And I can kind of color code that if you want. That's going to be this orange section here. And that's the cardioid part. I'll put that in orange. And then the circle part, that would just be this quarter of a circle. That's real easy. That's just the circle that's... And let's do that over here. And that's the circle part, which is just 1/4 of the circle. So if we add this up, we're going to find the area that's shared by the circle and the cardioid right over there, the part of that's in the cardioid and also in the circle. Okay, this is in the circle but not the cardioid. This is in the cardioid but not the circle. So we want the orange and the green. So this is going to give me the orange going from 0 to pi over 2, just the cardioid. There's my formula. 1/2 r squared d theta. And the circular part is just 1/4 the area of a circle. So, I mean, I just showed you that you could integrate this 1/2 r squared d theta. You could just integrate this from pi over 2 to pi. It would work out to be pi. Or you could just take 1/4 of a circle. The area of a circle is pi r squared. The radius is 2, so it's 1/4 of a circle whose area is 4 pi, so it's just pi. So there's a couple ways to do that. That's not the issue. Okay? The issue is finding the orange area here and adding that. Now that's just going to give me the top part, so we'll double the whole thing. And we use symmetry to double the whole thing, and we'll get what they want, which is this whole part in here. Okay? Alrighty, so I hope that makes sense. Kind of looks like the whole part here is this kind of little strange little, looks like a kidney bean type thing, okay? Alright. Alright, hope that's okay. Okay, so first of all, let's find this, and we're going to take the whole thing and double it, so we want to find this, and so we'll just have to work this out. So this is going to be, so we got the 1/2, and this is my r squared, this is r squared d theta. So I could square that. 2 is 4, and I could square this. And I just wrote it out squared like that till I square it out. And then I could put this out in front, so 1/2 of 4 is 2, so that goes in front. And I'm going to take the integral from 0 to pi over 2. And what you're going to do again is you're going to take this area from here, and this is just the cardioid, so don't worry about the circle, so you're just going to get that orange part. Okay? So I'm going to square this out. So 1 minus 2 cosine of theta, cosine squared of theta, and then we've got to use our good old reduction formula over here. Remember the cosine squared of theta, our two-angle formula is 1 plus cosine of 2 theta over 2. This is okay, and that's okay. Now I've got to doctor this up. Well, first of all, I separated this out, so I put this 1/2 over here. I separated this 1 over 2 and the cosine of theta over 2. Okay? And I kind of skipped some steps here. You probably don't like that. So let me fix this over here. So this is plus. And then I had 1/2 of this Okay? Like this. Okay? So we separated this, so this is going to be 1/2, and then 1/2 the cosine of 2 theta. Now the problem is that I want to get this into the integral form, so I need a u du, cosine of u du. So the cosine of 2 theta is what? That's just going to be 2 d theta, so I need a 2 here, so I put a 2 out here. And then if I put a 2 out here, I got to put a 1/2 in front. Let me give myself a little more room even. So you can see how I do that. I skipped some steps in this, and, I should never do that. So that 1/2 that comes out here is to balance that 2. 2 over 2 is 1. I need a 2 here to get this to be the cosine of u du. Okay, that's why I got the red 2 and the red 1/2. The regular pencil 1/2 came from my reduction formula. Okay, and now I've got this all set. I should probably keep this in red. See where that came from. And 1/2 times 1/2, and then I could take this 1/2 and add it to 1, and I get 3/2. So I get 3/2 minus 2 cosine of theta, which is integrable. That's easy. And then I got 1/4 this. So I'm ready to take my antiderivatives, and I'm going to evaluate that. I still have this 2 over here. And this is still the top part. Okay, so I got 3/2 theta, and the antiderivative of the cosine is the sine, so minus 2 sine, and the antiderivative of the cosine of 2 theta times 2 is the sine of 2 theta. Okay, and 1/4 in front. So if I evaluate this, this is going to be pi over 2, so this is going to be 3 pi over 4, and then the sine of pi over 2 is 1, so that's going to be minus 2 times 1. Okay, plus 1/4, and this is going to be, again, this will be 2 times pi over 2, which is pi, and the sine of pi is 0, so that's just going to be 1/4 of 0. Now, if I look at the 0, this is going to be 0, sine of 0 is 0, and then sine of 2 times 0 is 0. So this is all zeroed out, so this is all I've got. So this zeroes out, so I've got 3 pi over 4 minus 2, and then if I multiply this by 2, I've got this. So the cardioid part is 3/2 pi minus 4, and then the chord of the circle we found out was pi. So I can add all those up. So I have 3/2 plus 2/2 is 5/2 pi minus 4. So that's the top part. But if I double it, there we go, I'm sorry about that. Okay. So again, I'm simplifying over here, and again, I'll just go over this. This is 3 pi over 4 minus 2. This is 0. And then if I multiply that by 2, I get 3/2 pi minus 2 times 2 is 4. And this was the fourth of the circle. This is that quarter part of the circle. There's a couple ways I did this over here. Okay? And then that's going to be 2 pi over 2 plus 3 pi over 2 is 5 pi over 2 minus 4. But I have to multiply that by 2 because this was just the top part of our little kidney bean. So this part over here, this is just this over here. Okay? In other words, this is the 5/2 pi. Well, I'm sorry, this is the whole thing. So this whole thing is 5/2 pi. I'm sorry, this is the 3/2 pi minus 4 over here. That's the 3/2 pi minus 4. That's that orange part, and then this is the green part. And we should do this again. So this is the orange part here, above. And there's your green part. I'm going to color code these down here, and this is the green part over here. But that's just the above part, but that's just the top part, so I want to double that. So first of all, when I combine this, I get this, which is the top part. That's the red and the green. Or red and the orange and the green, pardon me. Okay? And then I want to double that so I can get the bottom part down here. So I have to double it to get this. So I multiply that by 2, so I end up with 5 pi minus 8. So that's your final answer. Now there might be an easier way to do that as far as the calculations are concerned. I don't know. As far as what order you do it in, but that will give you basically what you're looking for. Okay? Hope that helps.